So I just wanted to go over a couple basic things about lymphocytes. I know we've talked about them some, but a few things about size and then numbers and different types of lymphocytes that you might see. So this first image right here, that is actually a normal lymphocyte, and they tend to have a very scant amount of cytoplasm. That's this part in here. And they have a very condensed chromatin in their nucleus, so it's very clumped and you don't see much white through it, and the nucleolus is really indistinct. This cell, next cell right here, this is a reactive lymphocyte. They tend to be a little bit larger. Their cytoplasm is more basophilic. They may have this paranuclear clearing, which is a Golgi, and their chromatin is a little bit more lightly clumped, so it's slightly more active than the other. In general, small lymphocytes are going to be smaller than a neutrophil, so this is actually a neutrophil, and there's something wrong with this animal. And here's a lymphocyte, and you know when you're a clinical pathologist when you only have pictures on your iPhone of cells that you see while you're on duty. And so this actually is a dog who has MPS, it's a lysosomal storage disease, but it's a nice illustration of a lymphocyte that is actually smaller than the neutrophil, which is normal. And it has that eccentric nucleus and clumped chromatin. What's abnormal is both of these cells have granules in the cytoplasm. Now, lymphocytes can have granules in the cytoplasm, occasional ones, and they're just T cells or NK cells, but neutrophils shouldn't. And when you have lots of cells that are granulated, in this case it was a storage disease, but I just included this picture because it was a nice difference between the small lymphocyte versus the normal size of a neutrophil. So remember that dogs, cats, and horses, their primary leukocyte, of course, is the neutrophil, but cattle and rodents and some others, their primary leukocyte is the lymphocyte. And large animals, cattle and horses for that matter, have small and large lymphoid cells. So they can have both types of lymphoid cells, and rodents for that matter, but dogs and cats don't, they normally only have small lymphocytes and maybe some reactive ones. All right, so as a quick review of lymphopoiesis, just to kind of go through what happens, we start off as a multipotential lymphoid cell. This guy arises in the bone marrow, so here's our bone marrow, and this can arise to either a common B cell or common T cell progenitor. The common B cell progenitor goes to the bone marrow, and that's kind of its primary place of learning. And then the common T cell progenitor goes to the thymus. So that's your primary lymphoid organs. So after they mature in the primary lymphoid organs, they then go to the secondary lymphoid organs, and those include the lymph nodes. So now we're going to have lymph nodes, things like the spleen, the GI lymphoid tissue, so the gall, you can have tonsils, any of those kind of secondary lymphoid tissues is the next place where the actual lymphoid cells go. And why this is important is because the number of lymphocytes in the blood and in peripheral tissues is not a result of bone marrow production, so increased or decreased. Bone marrow disease doesn't directly impact lymphocytes unless the disease also affects secondary lymphoid organs. And so within the secondary lymphoid organs where the lymphocytes now reside, there's a mixture of T and B cells, whereas in peripheral blood it's mostly T cells. And in these secondary lymphoid organs, cells can, under antigenic stimulation, result in a clone, and then they can become these short-lived effector cells, resulting in antibody production or anti-cell activity against foreign material, or they can become long-lived memory cells. But in the secondary organs, it's a mixture of B and T cells, where in the blood it's primarily T cells. So when we actually talk about blood numbers of lymphocytes, we're going to kind of talk about the fact that there's a constant flux between lymphocytes in blood, lymphocytes in tissue, and then lymphocytes in lymphoid organs, and then heading back from the lymphoid organ into the thoracic duct. And so just like in neutrophils, lymphocytes have a marginal pool, and they have a circulating pool. And so some of the same things that we talked about that affect neutrophils are going to affect lymphocytes. So lymphocytes can leave the blood, and this can happen under the effect of cortisol, where they actually go to lymph nodes to wait for antigen, Lymphocytes can leave blood and then go into tissue to survey for antigens. They travel back via some sort of lymphatic vessel into the lymph node where they can then present antigen, or they can head back through the thoracic duct and then back into the blood. So you can imagine that if lymph nodes present, if there's a lot of antigen being presented and you have lymphoid hyperplasia, that's going to result in increased numbers of lymphoid cells potentially. So when we talked about chronic inflammation, that's one of the things we're going to talk about, is the fact that chronic inflammation and lymphoid hyperplasia can result in a lymphocytosis. So that's one kind of thing to consider. Numbers of lymphoid cells when they leave the blood due to cortisol and they go to lymph node would cause a lymphopenia. And any type of neoplastic proliferation of lymphocytes, no matter where it is, could cause a lymphocytosis. The last thing to sort of be cognizant of is the thoracic duct is very rich in lymph, so lymphocytes, and then because it takes back all the lymphatics from the intestines, take back sort of fatty rich material, and that's triglycerides in the form of chylomicrons, you're going to have a white milky fluid in your thoracic duct, and that's due to the triglycerides or chylomicrons, but it's also very lymphocyte rich. Now we're going to move on and talk about different types of lymphoid diseases or lymphocyte proliferations and decreases.